Okay, molecular compounds. Molecular compounds contain nonmetals, and nonmetals form negative ions. So if we try to look at these in terms of ionic charges, we are not going to get very far, because nitrogen and oxygen actually form 6 different molecular compounds. It's really kind of crazy. But if we're trying to predict how nitrogen and oxygen would go together using the rules for ionic compounds, nitrogen wants to be a -3 ion, oxygen likes to be a -2 ion. How can you add -2 and -3 and get 0? You can't. So that's not going to work. So we have to have a different set of rules for naming these molecular compounds. So these are 6 different combinations of nitrogen and oxygen. We can't just say, oh, it's nitrogen oxide. Which one, right? So remember that molecular compounds are composed of 2 nonmetals. Those are the ones that we're going to learn how to name. There are a lot of others that contain more than 2 nonmetals, but we're not going to learn how to name those. We're just going to do 2 nonmetals. These are the prefixes that we use to tell each other how many atoms of nitrogen, how many atoms of oxygen are in a molecule of this. And so you'll notice these are the same prefixes that we use for the hydrates. You should memorize these. They're very useful. Hexa, think hexagon. How many sides does a hexagon have? 6. Triangle, how many sides? 3, right? So these relate to geometry. These are Greek prefixes, and they're used in all kinds of different places. So what we do is we put a prefix in front of the element name to tell us how many atoms of that there are, and then the last element changes the ending of its name. There is a specific order, and I'm going to explain to you what it is. You actually probably won't have to use it much. So the order is that the more metal-like element goes first. They're both nonmetals, but some of them are more like metals than others. So different ways to think about this. This is a general way. The element with the smallest group number, so the one that's farthest to the left on the periodic table, if they're in the same group and you're trying to figure it out, then it's the element with the greatest row number, is the more metallic one that goes first. So let's look at the periodic table. We've got that stair-step line dividing metals and nonmetals. The way I like to think of it is you look, say, sulfur and fluorine. Well, which one's closer to the metal side? Sulfur. So I should put sulfur first. In the ionic compounds, it's always Mr. and Mrs., metal and nonmetal. So here we've got 2 nonmetals, but we're going to put the one that's more like a metal first. It isn't a metal, but we have to choose somehow, and that's how we choose. So here's the overall pattern. A prefix in front of the name of the first element, a prefix in front of the name of the second element, but we change its ending to "ide." Just like we often omit writing the number 1, like in this formula, NO2, we don't write N1O2. We also often omit the prefix mono, especially if it's in front of the first element. So there are some kind of odd little things that happen. I will not try to trick you with this. So this would be nitrogen dioxide. There's 1 nitrogen and 2 oxygens. So if this was a multiple choice question, I would not put nitrogen dioxide and mononitrogen dioxide on there in an attempt to trick you. Okay, I won't do that. There are 2 elements that are kind of special, H2O and NH3. I think we all know the name of this. H2O is water. Could it be given a systematic name? Sure, it would be dihydrogen monoxide, which is great for scaring people, right? Oh, you just drank dihydrogen monoxide. Okay, well, good. You're going to stay hydrated in the heat. Awesome. But it sounds scary. NH3 is another one we need to know the name of. That's ammonia. That's its common name. It's just always called that. It would be nitrogen trihydride, but nobody calls it that. Okay? It's kind of like, there's some famous people like Cher. I'm sure she was born with a first name and a last name, right? But she just goes by one name. So these are like the movie stars of the chemical compound world or something. So just a cautionary word. Students like this system of naming, right? And so then the tendency is, oh, well, let's just use it everywhere. 2 nonmetals. Only 2 nonmetals, okay? So naming this compound, N2O5. We need a prefix to tell us how many nitrogens, right? So dinitrogen.
Sounds like you're telling nitrogen to die.
Dinitrogen. I like that. Dinitrogen, and then 5 is penta, right? Penta oxide. Okay. Sometimes what we'll see when we have 2 vowels here is that the ending vowel on the prefix will get dropped. An example of that is carbon monoxide. So carbon monoxide is spelled with only 1 O in there. It should be monoxide. Monoxide. That looks weird, doesn't it? So here we drop this vowel. So sometimes you'll see it dropped, and sometimes you won't see it dropped. You say, I've seen it both ways. I won't try to trick you with that either. But if that vowel seems to be missing, just oh, it's one of those. Okay. So just do your best on that one. Writing a formula: phosphorus tribromide. P. Br3. So in the name, the number indicator comes before. In the formula, the number indicator comes after. So this is meaning 1 phosphorus and 3 bromines. Phosphorus tribromide, or PBr3. Questions? Another group of, or a subgroup of molecular compounds are acids. There are different definitions for acids. The one we're going to use here is that acids are molecular compounds that release hydrogen ions when dissolved in water. Hydrogen is that little guy on the element periodic table that just likes to break all the rules. So hydrogen's sitting over there with the alkali metals in group 1, even though hydrogen is not a metal, right? Hydrogen's a gas at room temperature. But it's over there because hydrogen forms a positive 1 ion. So an acid is a molecular compound. It's not an ionic compound, but when you put it into water, it forms ions. It's kind of crazy. Acids have hydrogen, which is usually written first in the formula, and that will be the case in this class. The hydrogen comes first, and then there's 1 or more nonmetals after that. So this is an example, HCl. That's 2 nonmetals, right? That's a molecular compound. We could name that hydrogen monochloride. When you put it in water, it forms hydrogen ions and chloride ions. And this AQ in parentheses stands for aqueous, and that means it's dissolved in water. So we're going to, let's see here. So HCl, if it's pure, is actually a gas. And so if it's a gas, you would name it hydrogen monochloride or hydrogen chloride. If it's dissolved in water, we name it as an acid. I'm not going to try to trick you with these either. But the book is pretty consistent, and I'm going to try to be consistent in whenever it's an acid and you should name it as an acid, it's going to have AQ behind it because it's an acid. It's named as an acid when it's dissolved in water. Acids have some characteristics. They taste sour. You know why Sour Patch Kids are so sour? Because they have acid on the outside. Not the drug acid, but I think it's maleic acid and citric acid. It's different natural acids. Acids will dissolve many metals, not all of them, but many of them. Here's an example of we've got zinc metal in hydrochloric acid, and it dissolves the zinc. It forms hydrogen gas, zinc ions, and the metal disappears after a while. And in this class, the formulas are going to start with H. Of course, it couldn't just be one kind of, one set for acids. There's two kinds of acids. So your book talks about binary acids and oxyacids. I prefer to focus on the oxyacids, and then everything else is in that group. So an oxyacid is an acid that has oxygen in it. If you have an acid that doesn't have oxygen in it, it belongs in that group. Okay? So let's look at what the book calls binary acids. These use a prefix hydro. So hydro is the prefix in front of the base name of the nonmetal. And then you change the ending of that name to ic, and then you add the word acid. So it's going to have two words, hydro something-ic acid. So let's name, that. Okay, so let's name this. So we look, it's two nonmetals, there's no oxygen, so we're going to use that prefix hydro. And then I heard somebody say it, we take fluorine and it becomes fluoric. So hydrofluoric. Remember, there's no flour in fluorine. Fluorine is gluten-free, right? Hydrofluoric acid.
What is that used for?
Hydrofluoric acid is used for etching glass, actually. It's, that's nasty stuff. You get a concentrated solution of that, it'll eat up all kinds of stuff. You can't store it in glass bottles because it will gradually dissolve the glass.
So it would be plastic containers?
Yeah, you have to store that in plastic containers. Yeah. Any questions? The oxyacids have oxygen. So they're going to have an oxyanion in them. We've already learned the oxyanions. These are the things like chlorate and hyposulfite and things like that. So what we need to do is we need to identify the name of the oxyanion, and then we're going to alter its name to make it an acid. So if it ends in ate, we're going to change the ending to ic. If the ion name ends in ite, we're going to change it to us. And then we put the word acid at the end. So how do you remember that? Well, the sentence I've always used is Rick ate him before he could bite us. I know, right? That's silly. Rick ate him before he could bite us. Now, what is he? I don't know. What is something that could bite you that you would eat? Oops. I have to stop saying other things while I'm trying to write. Rick ate him before he could bite us. So how does that help us? Well, here's the ick and the ate go together. The ite and the us go together. Another one that students sometimes use is the white mouse ate icky cheese. The white mouse. So there we've got the ite and the us together. The white mouse ate icky cheese. I didn't plan ahead very well there. There are a lot of things in chemistry I've noticed where we have like this. We have ate and ite, we have ick and us, and we have to match them up correctly, and it seems kind of random, right? I can't just remember that stuff. I use tricks like this to keep them together in my mind. So I'm just trying to share that with you guys. So whichever one you like, that's one way to keep them straight. Okay, so let's name an acid. So here we've got HNO2 aqueous. We look at this, it starts with H, that's how we know it's an acid, and we see it has oxygen in it. So this is an oxyacid, and so what we're going to do is we're going to cover up the H and look at the rest of it. Right, so that is NO2. And so that has the name nitrite. Why is its name nitrite? Because it's one less oxygen than nitrate. Why is nitrate's name nitrate? Because it just is, that's its name. So this is nitrite. So then we change ite to us. And so this is nitrous acid. Okay? No hydro in front. Hydronitric acid would be H3N, no oxygens. So that's nitrous acid. Any questions? You have to identify what the oxyanion's name is, change the ending, Rick ate him before he could bite us, and then slap the word acid on the end. Write the formula for perchloric acid. The great thing about these acid names, they're very easy to recognize as acid names, right? It's got the word acid in it. How nice is that? What kind of an acid is this, though? Is it a binary acid or is it an oxyacid? It's an oxyacid. We can tell because it does not start with hydro. If it starts with hydro, you've just got hydrogen and one other thing. So this is perchloric acid. So perchloric comes from the name of the oxyanion. Ich and ate go together. This comes from the perchlorate ion. So we need to write the perchlorate ion. Chlorate is ClO3 with a -1. Perchlorate has an extra oxygen because it's hyperoxygenated. ClO4 has a -1 charge. How do we make this into an acid? We combine it with hydrogen ions. Okay? Put them together. This has a -1 charge, so this is going to need 1 hydrogen. And so we're going to write the formula HClO4, and then, just to be strictly correct, put aqueous after it. Some acids have more than 1 hydrogen ion. If the oxyanion has a charge of -2 or -3, then you're going to need 2 or 3 hydrogen ions. So we just wrote a formula, but here are the instructions. If the name ends in acid, the formula is going to start with an H. Write the formula as if it were ionic, even though we know it's molecular. But when it goes into water, it forms ions. And so we use the charges to tell us how many of each thing we need. The hydro prefix says it's a binary acid, hydrogen and something else. If there's no prefix hydro, that means it's an oxyacid. And you do it based on the name and the formula of the polyatomic ion, the oxyanion. So here's a couple extra examples. So hydrocyanic acid, what kind of an acid is that? It's a binary acid. It starts with hydro, right? So then what we need to do is we need to look at the element name. Wait a minute, cyanic, is that? Yeah, that's cyanide. It's not an element. This is why I don't like the term binary. So cyanic, cyanide. Right? That's the formula for cyanide because you memorize it. And then we have to put a hydrogen ion with that. We look at the charge, -1, so we only need 1 of these. We shove them together, and this is HCN.
Is hydrocyanic acid
Well, anything with cyanide in it is potentially lethal, yeah. So this falls into the naming category of binary acids, but the definition given earlier is that it's hydrogen and one other one of those, a nonmetal. This has 2 nonmetals, so that's why I don't like the term binary. I prefer to focus on, okay, these are oxyacids, and then there's the other kind. The other kind uses the prefix hydro. So let's write formula for phosphoric acid. What polyatomic ion does that come from? Phosphate. So we're going to change the ic to 8. So this is from phosphate. We need the formula for phosphate. PO4, 3 negative. You know, if you're still a little sketchy on those, keep your flashcards with you. Keep going through them, because these guys are going to be with us all semester. How many hydrogen ions do I need to put with that? 3. Because there's 3 negative charges. So this is H3, PO4, aqueous. Any questions? Hypochlorous acid. Oxyacid or other kind? Oxyacid. So hypo and hydro are kind of similar, right? But this is not hydrochlorous acid. Hypo. So this comes from hypochlorite with his 1 less oxygen than chlorite. Chlorate is ClO3. Chlorite is ClO2. Hypochlorite is ClO. So ClO, and it has a -1 charge. Because we just have to remember it. How many hydrogen ions does it need? Just 1. So this is HClO aqueous. Any questions? This requires some practice. So making mistakes, getting corrected, learning from the mistakes. There are several assignments on mastering chemistry that'll give you practice with this, and those are for a little bit of extra credit. Yes?
What's the difference between NH3 and NH4?
NH3 and NH4, what's the difference? That's a good question. So NH3 is ammonia. NH4 is actually an ion. That's ammonium ion. And so you can't have NH4 by itself. It would have to be with something else, like chloride or something, ammonium chloride. Pardon me?
Are they entirely different compounds?
They're not really entirely different. They are definitely related to each other. Because ammonia becomes ammonium by accepting a hydrogen ion. And ammonium can turn into ammonia by donating a hydrogen ion. So they go back and forth a lot. But they're not the same thing. Any other questions? You should read that section. I'm not going to test you on it, but short. Some pollutants mix with water in the air. They make acid. It falls down, and it's not good.